So today we have an interesting geometrical problem. The diagram is on the screen with all the given details. Now the question over here is to find the value of the missing angle that has been taken as a variable theta. So this is Anmol, and now let us see the solution. How can we solve this problem? So first of all, I will start the solution by marking the side lengths of this quadrilateral as variable. So let the length of this particular side be equals to A, the length of the second side be equals to B, length of this side be equals to K, and finally the length of the fourth side be equals to a variable M. Now to move further in the solution, I will take help of the triangle ABC and the other triangle DBC. So for that, I'll just simply redraw this triangle outside this diagram. So let us draw the triangle ABC first of all. So the triangle ABC is like this, this and this. Here is the angle theta. This angle over here is the angle B. So the value of angle B according to this diagram is 70 plus 40 degree, and that is going to be 110 degrees. Now by angle sum property, the value of the third angle is going to be 180 degree minus 110 degrees plus theta. Okay. The value of this particular side we have already taken as a variable A, and also the length of this side we have taken as variable, and that is equals to K. Now in this particular triangle we will apply the sine rule. Therefore sine of theta upon its opposite side, that is K, this thing would be equals to sine of 180 degrees minus 110 plus theta upon its opposite side, that is A, and this thing would be equals to sine of 110 degrees upon this opposite side. So we'll simply not take this ratio because that is not required. Okay. Now we know this particular identity of trigonometric ratios, that is sine of 180 degrees minus some angle A. This thing is equals to sine of A. This is an trigonometric identity, so we can go ahead and apply this identity in the numerator part over here. So sine of 180 degrees minus 110 plus theta will simply turn out to be sine of 110 plus theta. Now I will do the cross multiplication in order to get the value of A in terms of K. So the value of A we will get would be equals to K times sine of 110 plus theta divided by sine of theta. This is the value of A in terms of K. So by using this first triangle, we have got the value of A in terms of K. Now let us take the second triangle, that is the triangle DBC. So the second triangle, let me draw it outside the diagram. So the triangle is DBC, and it is like this, this and this. Here is the point D, the point B, the point C. Now the angle at point D is 20 degree. The angle at the point B is 40 degree. Length of this particular side is equals to B, and length of this particular side we have taken as a variable K. Now I will apply the sine rule in this triangle. Therefore sine of 20 degree upon its opposite side, that is K, this thing would be equals to sine of 40 degree upon its opposite side, that is B, and this thing would be equals to sine of this particular angle upon this side, and that ratio we don't, so no need to take it. Okay. Now we know this identity, that sine of 2 times A is equals to 2 times sine of A multiplied with cos of A. Now by replacing A as equals to 20 degree, on the left hand side we will get sine of 40 degree, and this thing would be equals to 2 times sine of 20 degrees multiplied with cos of 20 degrees. So here we have got the value of sine of 40 degree in terms of other trigonometric ratio. So over here I will replace sine of 40 degree with this value. Therefore the first ratio as it is, that is sine of 20 upon K, this thing would be now equals to 2 times sine 20 into cos 20 divided by B. Now sine 20 and sine 20 can be factored out because sine 20 is not equals to 0. Now by doing the cross multiplication, I can get the value of B in terms of K, and that would be B equals to 2 times cos of 20 degrees multiplied with K. So here we have got the value of B in terms of K. So till now what we did is the half part of the solution. We simply applied the sine rule in the triangle ABC and the triangle DBC in order to get the value of A and B in terms of K. Now we will see the second part of the solution, in which we are going to utilize these equations. Now to begin the second part of the solution, I will first of all take the triangle ADB. So first of all, I will draw this triangle outside the diagram. Here is the point D, A and the point B. The length of AB is equals to A, this length is equals to M. This angle we don't know, this angle is equals to 30 degree and this angle is 70 degrees. Now by applying the sine rule, we can say that sine of 70 degree upon its opposite side M, this ratio would be equals to sine of 30 degrees upon its opposite side, that is A. Now recall that we have got the value of A in terms of K, you can see that over here. So the value of A is equals to K times sine of 110 plus theta divided by sine of theta. Now we can rearrange this fraction, so this thing will turn out to be sine of 30 degrees multiplied with sine of theta divided by K times sine of 110 degrees plus theta, and this thing is equals to sine of 70 degree upon M. Now by doing the cross multiplication, we can get the value of K upon M, and that would be sine 30 into sine theta divided by sine of 70 degree into sine of 110 plus theta. So here we have got the first value of K upon M. Now let us try to get the second value of K upon M, and that we can get in the triangle ADC. So the triangle ADC is like this. Here is the point A, the point D, the point C. The length of AD is M, the length of DC is equals to B. This angle over here is 30 plus 20, that is 50 degrees. Now what about the other angles? So we can get that thing using this diagram. So in this diagram, take the triangle ADB. One of the angle is 30 degree, one of the angle is 70 degree. Therefore, by applying the angle sum property in this triangle, the value of this particular angle would be 80 degrees. Now out of 80 degrees, some part is already equals to theta. Therefore, the remaining part, that is the angle DAC, would be equals to 80 minus theta. So we can see that we have got the value of the angle DAC, and that is 80 minus theta. Now in this triangle, by applying the angle sum property, the value of this particular angle would be equals to 180 degrees minus 80 minus theta plus 50, that is 130 degrees minus theta. Now I will apply the sine rule in this triangle. Therefore, one of the angle is 80 minus theta. So sine of 80 minus theta upon its opposite side, that is equals to B. This thing would be equals to sine of 180 degrees minus 130 minus theta. So as per the identity I told you before, this thing will turn out to be 130 minus theta upon its opposite side, that is equals to M. Okay. Now previously we have got the value of B in terms of K, that you can see over here. So the value of B was 2 times cos 20 into K. So I'll replace that value over here. So B will get replaced with its value, that is 2 times cos 20 degrees multiplied with K. Now by doing the cross multiplication, I can get the value of K upon M, and that would be equals to sine of 80 degrees minus theta divided by 2 times cos 20 degrees multiplied with sine of 130 degrees minus theta. So here we have got the second value of K upon M. So here we have these two equations. The left hand side of both of this equation is equal, hence we can compare their right hand side. Now in the right hand side of this equation, we can do some changes. We know the value of sine of 30 degree, that is 1 upon 2. So 1 upon 2. Now using the complementary angle, we know that sine of 70 degree is equals to cos of 90 minus 70, and that is simply cos of 20. And 1 upon 2 in the numerator will come in the denominator. So this thing will finally turn out to be 2 times cos 20. Now we can see that cos 20 is not equals to 0 and 2 is also not equals to 0. So these both things can be factored out from both of the side. Now we can cross multiply the remaining terms. Now I will use a trigonometric identity, that is 2 times sine of A multiplied with sine of B is equals to cos of A minus B minus cos of A plus B. So we can see that the same pattern is present in this equation except 2. So what we can do is we can simply multiply 2 on both of the side. Okay. So now we can see that the exact pattern is present in the left hand side also, in the right hand side also. So by using this identity, left hand side would be equals to cos of 110 plus theta minus 80 plus theta, and that is going to be 30 plus 2 times theta minus cos of addition of this both. So that would be simply 190 degrees. This thing would be equals to cos of 130 degrees minus 2 theta minus cos of 130 degrees. Now I will rearrange some of the terms. So I'll simply move this term on this side and this term on that side. Now we have one more trigonometric identity, that is cos of A minus cos of B equals to 2 times sine of A minus B divided by 2 multiplied with sine of A plus B divided by 2, and all of this term negative. Okay, cos of A minus cos of B is equals to negative 2 times sine of A minus B upon 2 into sine of A plus B upon 2. So the same pattern is present in the left hand side also, in the right hand side also. So by applying this identity, the value of the left hand side would be negative 2 times sine of 2 times theta minus 50 multiplied with sine of addition of this both. So 30 plus 2 theta plus 130 minus 2 theta is going to be 160 divided by 2 is 80 degrees. Okay, this thing is equals to negative 2 times. Now by applying the identity on the right hand side, we have cos 190 and cos of 130. So negative 2 times sine of 190 minus 130 upon 2, that is 30 degrees, into sine of 190 plus 130, that is 320 upon 2, that is going to be 160. Now as I told you, the identity of sine of 2 times A, that is equals to 2 times sine A into cos of A. In this we can replace A as equals to 80 degrees. So we will get the value of sine of 160, that is going to be 2 times sine of 80 into cos of 80. So this sine of 160 can be replaced with this value. So sine of 60 will be replaced as 2 times sine of 80 into cos of 80. Now I can see one more thing, that is sine of 30 degree has a value, and that is 1 upon 2. Okay, now negative got cancelled out, 2 and 2 got cancelled out, 2 times sine 80, 2 times sine 80 got cancelled out. So the final thing that is remaining is sine of 2 times theta minus 50 degree equals to cos of 80 degrees. Now we know by complementary that cos of 80 degree is same as sine of 10 degrees. Okay, now we have the same trigonometric ratio on both of the side, hence we can compare their angles, and both of these angles are going to be in the first quadrant, so we can simply compare them. Therefore 2 times theta minus 50 equals to 10 degree, and when you will simplify this equation, you will get the value of theta, and that is 30 degrees, and that's the answer that we were looking for. So this was my way to solve this particular problem. If you have any other method other than this, do comment below, and if it's hard to comment, you can email me, or else you can send it to me on my Instagram. The link is in the description.